You everyone. Welcome back from lunch. The sessions I've been watching the play-by-play from the AutomaTech team on LinkedIn this morning, and they've been sharing both some of the points that the other presentations been making, and then some of the Q&A. So I'm hoping we can continue that trend, and please make use of the Q&A tab, and we'll make sure we get to your questions toward the end of the half hour. So my goal today is really twofold. I want to talk about two things. The first is similar to what Tom was just talking about, another approach for figuring out what you have. And then secondly, a practical method to show what you can do about it. The idea here with Bayshore is we try very hard to offer up solutions that are really going to work with the staff you already have, the tools you're already using as a wraparound approach. And so we try to make these things approachable and not so complex that they are essentially overwhelming. And the stuff I'll show you this afternoon, I think, is really designed to focus in those two areas, and look forward to running you through it. So let's dive in. What's on your network, particularly what's on your OT network? I mean, this is a very fundamental objective, and I know you've heard about this in other themes from presentations earlier today, and undoubtedly crossed paths with it before. What is on your network? What is it where you expect it, and why is it doing whatever it's doing? These are not meant to be insultingly simple questions, although I know sometimes it feels that way when vendors sort of put them to you. But the goal is not to illustrate negligence or anything like that. It's to accept the reality that these networks get complex quickly. Their very nature is permissive, right? The idea is networking, not the opposite of networking. And so as you build in a network, you discover all these things you can do, and that's great. But with the passage of time and the changing of staff and the shifting of priorities, it's unusual not to find a network that has somehow drifted away from what people think is there. And so that leads us to the last question: what else is out there? And in order to figure out a strategy, particularly with regards to security, you really have to have some handle on some of these questions. And there are some fantastic tools and methods that you can buy to do that. And I'm going to share one with you that you don't have to buy at all. So I'll tell a little story first. This was from a recent installation where Bayshore installed a SCADA fuse, which is an industrial firewall product I'm going to show you in a little while. Big site, lots of different buildings across a large geographical area. And it was about a 10-minute walk back to the control room. So we set up the SCADA fuse, we had it running, it was learning activity. And during that 10-minute walk, it picked up a Windows workstation that the customer didn't realize was powered on and active. And it was running a programming tool looking for PLCs that it could talk to. And it was just quietly polling the network, looking for these things and trying hard to, do a good job and show you all its available assets, and that's fine. But the challenge is, A, of course, here was a workstation that people thought had been turned off and deprecated, and it wasn't. And B, if it is configured not just to poll for assets, but to update assets, it could have conceivably updated the programming on a production asset. And that's dangerous. Clearly, we don't like that idea. It makes us uncomfortable, even though it's a tool doing a sort of legitimate task. It's not running a security exploit. It's doing a thing it's meant to do in a sort of honest and forthright way. And so on that premise alone, the customer indicated they wanted to move forward, with instrumenting their network with SCADA fuses, and they made that decision very quickly. And that was, great for us. Good stuff. Another story, again, to do with a recent SCADA fuse installation. We set it up, we did some initial learning, identified a couple of SCADA servers that were going to be talking to this one protected PLC during the evaluation. We left the device in monitoring mode for 2 weeks, and then went back to sort of follow up with it a couple of weeks later, and discovered it had logged over 2,000 events for unexpected communications. And they came from over 75 different assets with networking access to different subnets and all sorts of different protocol activity. And again, it's not necessarily that any of this was configured to do malicious or dangerous things, but it was creating activity which, with only very small changes, could have resulted in interference with production operations. And again, the question is, what's out there, and is it doing what you expect? So how does asset visibility help? Well, clearly we can't dictate, every piece of software and describe how it's allowed to work. We accept these tools that we buy and that our suppliers bring to us, and they do things. And there's a fundamental threshold beyond which we can't control whether or not they do all those things. That's just the nature of how they work. But we can manage their scope. So segmentation, I know, is a theme you've heard about already. Do we provide a limited degree of access in the network through a variety of segmentation techniques so that these tools don't have access that they don't need? Do we use policies to control, how much access we give? So, again, on a network, the predisposition is to be permissive, to let tools see and do stuff. But the danger there is that you create situations where they might have more access than they need, and certainly the ability to cause trouble that you didn't expect because they're overly permissive. And then finally, we end up with this notion of risk. How do we mitigate unexpected or dangerous communications, even from the tools that we have explicitly chosen to use? Again, I'm not focusing just on exploits and the guys in the dark hoodies. I'm interested in this notion of things happening using legitimate tools, but in unexpected ways. And that's the sort of practical risk that I think a lot of us have probably experienced firsthand one way or another. So a reasonable baseline is only as useful in terms of what assets you have. That baseline is only useful as your own ability to do something with the information. If I give you a 200-page report every morning in your inbox, I can safely assume that you're probably not going to get through it every day. So, we have to find a balance. We have to look at the available staff cycles, the available skill levels, and the ultimate priorities for what you're trying to do. And there are some wonderful commercial tools that do all sorts of great things. Really, really high quality tools for visibility and vulnerability management, asset management. They can be quite expensive. And again, they presuppose that you're in a position to take action on their findings. And we all know that in a lot of industrial environments, we don't have that luxury. We don't have a dedicated security investigation team. We don't have an operations center that is focused purely on security analysis. And so the challenge is, we may aspire to get to that level of security maturity, but if we're not there yet, if you're faced with an option of, not being able to use the fully featured tool versus doing nothing, I'd like to offer something that sits in between. And we call that tool scrutiny. So I'm going to play a little video. I'm hoping that the sound piece is going to work. Let me just double check that. I'm going to stop sharing for a moment. I'm going to go back. I'm going to make sure I turn on the sound this time.
Yeah, Toby, just one quick comment. Make sure you check that box to.
Yeah, I just remembered that, and so I've just gone and checked it back on. So, all right, here we go. So this is the introduction for Scrutiny. Scrutiny is Bayshore Networks' asset and flow visibility tool. It's available today at no cost. It's a tool for industrial network operators to get a handle on what's on their network and what it's doing. It works with live packet captures, or you can feed it offline PCAP files. In this case, we've specified a test environment with about a 4 megabyte PCAP file. If I click Generate Report, it takes about a minute to process that. And then we get this sort of interactive report. It shows a top level of the number of assets that have been discovered and the protocols that are in use, any obvious high criticality alerts to do with network configuration, and then you see a protocol breakdown. So I can see that for the total volume of traffic, my Modbus, for example, is about 9% of the volume. My S7 is about 4% of the volume, and there's a breakdown for others. My Ethernet IP is clearly the winner at 83%. There's an asset inventory table, so you can see all the discovered details, in this case the IP, whether it's routable, the MAC, any vendors we can identify looking up the particular owners for those MAC ranges. There's an asset diagram, and I can click on each of these clouds to look at the assets within each of those subnets. So in this situation, on this subnet, I've got a couple of different Siemens devices that are generating S7. I click on this one, I have a breakdown for Ethernet IP and other protocol activity, and you're able to see the flows and connections between those assets. And then finally, there's a more detailed breakdown by TCP and UDP for all the different flows, the quantities of connections, and the whole history and the detail from that live packet traffic that was captured. So Scrutiny is available today. You can register to express your interest in it at bayshorenetworks.com/scrutiny, and we look forward to hearing your feedback about it. All right. I'm hoping you could hear it. Matt, did the audio work?
Yep, all good.
Okay, cool. All right, well, let's move on.
So,
So,
it was you.
I'm sorry?
So
Sorry,
Chelsea, we've got a question here from the field with regards to scrutiny. Would you need one of those on each VLAN to be able to capture the traffic?
Depends on the visibility. It's not an appliance, it's just software. So if you do have segmentation already in place, you can simply carry your laptop from one segment to the next and do live captures incrementally. Or you can take a capture off existing equipment and just store it in an offline file. And you just specify all the different PCAP files as a project, and it'll do an aggregate analysis across all of them for you.
That's kind of cool. Another question that's sort of related, how do you configure it to capture multi-subnets? I guess you just sort of talked to that answer because it's not an appliance. You just connect it to each of the visible subnets and get your info from there.
Yeah, that's right. I mean, it's a Windows desktop application at the end of the day. So you run it as administrator and it'll switch your interfaces into promiscuous capture mode. And any packets that it sees on that local subnet, it'll capture. So if you're dealing with, again, a regulated situation, maybe you've got VLANs, maybe you've got physical separation, you would need to provide exposure to each of those individually.
Another customer asked about configuring the hardware. I guess the short answer in that case is you'd have to set up port mirroring so that you get access to some of the other traffic as well. And follow-up, how do you configure the SCADA fuse to handle that? And maybe just a quick description of SCADA fuse.
Well, that's exactly where we're going next. If we run through the other questions, are there any others, or we'll dive right into SCADA fuse?
No more at the moment.
Okay, perfect. Well, then that's a good segue. So part two, now what? So the idea here is we've identified assets, we know what they're doing, and if we've identified things that we were particularly concerned about, we go off and we mitigate those. You know, if my user story where there was this unexpected programming workstation, you know, the action was pretty straightforward. Go and find that machine and physically remove it. Because it wasn't meant to be there. It had been set up temporarily and then had been forgotten about. That was the simple answer. So you do some basic hygiene and cleanup, and what you end up with are the assets you know about and the flows that they use. And that's when you're going to find out that some of your PLCs don't just talk on their native OT protocol, they also may have a web interface or an SSH interface or some other thing that you occasionally need. And that's fine. You know, the goal is not to suppress all activity. The goal is to be comfortable that you know what activity is required. So you've done all that, and what do you do with, you know, going forward? And the most common situations are twofold. First of all, the scenario where you do need to enable additional access temporarily. And then secondly, when you discover that tools and equipment are doing things in an unexpected way, but they're able to do them because the network itself allows that type of activity. And maybe you want to do some kind of filtering or constraint on what that's supposed to be. So our answer to that is a product called SCADA fuse. And I made reference to it earlier on. We've done a number of installs of this recently with AutomaTech. This is an endpoint protection firewall. So this is fundamentally, this is different from your classic IT firewall in that we're not just putting it at the perimeter of the network. We're actually putting it in front of the assets of value. So if it's a cabinet, you know, we're putting it in the cabinet and we're protecting the PLCs that are in that cabinet directly. If it's a panel, same thing. Maybe you've got an HMI, maybe you've got a variable frequency system of some sort. We're going to protect those assets with an individual SCADA fuse. And the goal is twofold. First of all, to constrain activity from permitted sources. And secondly, to define what activity types are allowed to interact with these protected assets. So it's an inline device. For those of you who are into networking, this is a layer 2 transparent bridge, but it's doing full deep packet inspection of all of the content that moves through it, sort of like a layer 7 next generation firewall. It's oriented around native OT protocols. So we can do a full decode of every function code, all the payloads, all the parameter values for all of these different supported protocols. And the goal is that we want to organize them all into whether it's a read instruction, a write instruction, or a programming instruction. So a read instruction is pretty simple. You know, your PLC may receive an inquiry from your SCADA tool saying, tell me the value of this register. A write instruction is push this new value into that register. And a programming instruction, of course, is, let's upload a whole new set of logical instructions into this device. The goal with SCADA is to know all those relationships and allow the ones that you have explicitly permitted, and to protect the PLC from anything that hasn't been learned and enabled going forward. It has a built-in Modbus server, so it can be integrated into your SCADA systems, whether it's iFix, whether it's Simplicity, or any of these other tools. The idea there is that your control room is the first line of incident response. It's the facility you already have and the people who are already sitting there. And what they're looking at is whether or not the device has logged events, because events are situations that deviate from policy. It is a DIN rail enclosure, as you can see. It takes, DC power. It has redundant power supplies, and most importantly, it has a hardware network bypass. So if, for whatever reason, the SCADA fuse loses power, packets keep flowing. We do not cut off the equipment that's behind the SCADA fuse. You see it in your SCADA system that the device has gone offline, and we go and find out why, and take whatever action we need to. But in the meantime, the plant continues to operate the way you expect it to operate. There is also an iFix version of this, and it works in much the same way. The difference is, instead of sitting in front of PLCs and RTUs, it sits in front of your iFix SCADA servers. And it works with any 6.x iFix installation, and GE Digital worked with us directly to support their native protocol activity between the SCADA servers and the various other iFix node types, the view nodes and the thin and thick clients and everything else. The two basic models for the endpoint SCADA fuse, the standard device will protect up to 5 assets, and the premium device will protect up to 10. Same hardware, this is just a licensing distinction. The idea is that these are not expensive to purchase, they're easy to install, and most importantly, they learn on their own. So when you first deploy these devices, they build an automatic profile of all the rules necessary to reflect normal and safe activity. And it organizes it by protocol and by source and destination IP address, and then by function code for all the protocol activity. And I'm going to show you a little bit about how that works in a minute. So here's a simple use case. We have an HMI, it's on a switch somewhere up up on the network. We have a couple of SCADA fuses, one of which is sitting in front of an Allen Bradley device, another of which is in front of a VFD. And that's fair enough, no problem. We learn the activity between the HMI and each of those two protected assets. It'll be separate, different protocols, different function codes, but it learns those, it builds the rules, and then you put it into protection mode so that anything falling outside of those rules is no longer permitted. Use case number 2, now we have a situation with a single cabinet which may have multiple assets inside it, in which case the SCADA fuse sits in front of the switch on that cabinet so that it can protect all of the assets with a single piece of hardware. Works in much the same way. We identify the IPs, we look at the protocol activity, and ultimately we build the rules and allow the customer to either fine-tune them or just accept them as learned. Here's a more detailed description of how it's working. So when the device is in protection mode, it knows a list of IPs, sources and destinations, and the various protocols that are in use for protecting the assets behind it. When we switch it, the protection mode takes action whenever something comes along that falls outside of those rules. So now we have a new workstation that is connected to a switch and is trying to interact with the protected assets. The SCADA fuse recognizes that it's not allowed, and it simply blocks that IP address from doing anything. That's a pretty straightforward cut and dried scenario. But what happens if you have a learned IP and it normally has read-only access, but now it tries to do a write or a programming change? Same thing. Doesn't matter if you piggyback off the IP, the violation occurs because we see at the function code level because of the deep content inspection that the SCADA fuse is performing. So here's another use case. This is a pretty standard water plant. Typically there's a series of HMIs, there's a series of SCADA servers, probably some historians, all of which have interactions with the protected assets. And the goal is that these are typically open and relatively insecure networks. They used to be isolated, but now they may have some sort of connection to IT, and from IT maybe to the internet. You may use third-party network connections for long-haul data transmission between remote facilities. All of these things introduce the possibility of third parties having access. And again, the goal is not to classify all of that as malicious, but it doesn't mean it's not dangerous. And what we're trying to do is ensure that as a last line of defense, no matter what else happens, those PLCs are going to continue to take instructions only from the workstations that they're meant to, and only of the types of instructions that you deem necessary in order for the plant to operate. So let's show you a couple of demo videos of how this works. So this is the first one. Let me get play going here. So this, what you're seeing, just to set this up, this is the web interface for a SCADA fuse once it's initially configured and running. And these are all very short, so we'll just run through them.
When you first install a SCADA fuse, it doesn't know anything about the native traffic on your network. We put it into learning mode. And during that mode, what it's doing is looking at the native connection properties between sources and the protected assets behind the SCADA fuse itself. It observes all the content of that traffic through a deep packet inspection methodology, and it'll organize it based on the industrial protocols that are used, and then within that, the specific function codes that it sees. What we can see here is that it's observed some Modbus activity, and importantly, some Ethernet IP activity, but only in a read-only set of function codes. If we know that the source for that Ethernet IP needs to go and generate additional write-type operations, we can add that in one of two ways. Here we're switching the SCADA fuse into a monitoring mode. And in doing that, it's going to tell us when any deviations from the rules it's already learned take place. It'll record those in the events screen. And now what we can see here is that the source we know about has performed a write operation to the protected IP address of the PLC downstream on the network. We can simply click Add to the traffic learned, save that, and that new write permission gets folded into the policy that's already present on the device. Now we can go back to the dashboard and observe that the change for the policy has been implemented. It now permits write operations for that source on Ethernet IP, and thereafter, no events will be recorded.
All right, so that's the first part with learning. Now what we have is a situation where we've defined a policy and we want to add to it. So that's the next piece we'll show you.
SCADA Fuse provides extensive customization options for policies already in place after the initial learning period is complete. This device is operating in monitoring mode, which means it's logging events which are indicative of deviations from the rules that were previously accepted by the customer during the original learning period. But maybe we want to add one of these new source-destination pairs into the policy going forward. As we review one of the particular events, we see a new source IP targeting an existing protected asset. It's using Ethernet IP, but it's coming from a source we hadn't previously learned. If we want that to be part of the policy, with a single click of the box, we add it, we hit save, and then as we go back and review the individual rules of the policy itself, we'll see that that new source is now indicated as part of the policy for this device. It only used read operations in its function codes for Ethernet IP, but that's what we've decided we want to accept going forward. We can also look at the graphical representation and see that our Allen Bradley PLC now has two different sources that are permitted to talk to it, 10.6 and 10.100. Both of them are permitted, but the red indication shows that there are unacknowledged additional events between that particular source and the protected asset itself.
All right. And then the final one I'll show you, this is a situation where we've defined our policies, but now we need to make a temporary elevation of privilege. And this is the classic situation where you say, yeah, okay, go ahead and do XYZ, whatever you need to do. And then you forget to back out the access that you've permitted later on because everybody's busy. So this is how we deal with that particular situation.
One of the most important features of SCADA Fuse is the ability to provide schedule-based escalation of access privileges for a policy statement. This is useful for routine maintenance or for situations where unplanned upgrades or repairs are required. We're going to modify this existing read-only policy to provide full access to the destination IP for a 24-hour period which starts tomorrow and rolls over to the next day. Once we apply this change into the existing policy, it takes effect immediately, and you can see that full access will be permitted, but it's in a pending window which doesn't start until the trigger time tomorrow. For now, the privilege remains at read-only for this policy statement.
So I hope that makes sense. I'm just going to share one more use case, and then we're going to be wrapping up towards the end of the time block here. So this is a situation which we installed a SCADA fuse on the West Coast, which is, for many of you may know, this is earthquake country. And what we had was a local government authority which had previously run a traffic control system, which was at the time completely air-gapped from the rest of their public safety network. And the idea was that there was a seismic monitor, and if it detected an impending earthquake above a certain magnitude, it lowered the barriers to stop traffic from going through a tunnel that went under a river. And the concern, of course, was that if the tunnel ruptured with vehicles in it, that they would suffer casualties. But as part of a broader infrastructure upgrade, this network became connected to a larger public safety infrastructure. And as a result, there were suddenly a lot more potential avenues of connectivity, which they tried to design around, but they wanted an additional safety net. So they chose to use SCADA fuse as a way to protect the specific controllers from unauthorized triggers. And the goal was, okay, let's make sure that this PLC only takes instructions from this seismic monitoring station and nobody else, so that we remain confident that no one could, for example, generate a false alarm, which could result in different kinds of casualties if, for example, public safety vehicles could no longer enter the tunnel because the barriers were down unexpectedly. We do get asked questions about how SCADA fuse compares to firewalls. I mean, the main differences I touched on previously. The first is placement. So SCADA fuse is not meant to be a perimeter device, which is, of course, different from a lot of firewalls. The second is the native OT support. The goal here really is to be able to operate in the local vocabulary of all the equipment you already have. Not just what TCP port Modbus uses, but what all the function codes are, what all the different classifications are, so that you can build policies which are familiar. We all understand read versus write access. We all understand that programming access shouldn't be necessary for a historian to pull data from PLC. And pardon me, SCADA fuse lets you do that automatically as part of the learning. You don't need to write all the native OT protocol instructions. You just need to let it watch what's happening already on your network and confirm that you're okay with it. So I'm going to click through. I know there's some questions queued up, so let's rattle through those, and then we'll be able to close it out.
Okay, Toby, here they are, and I'll try to go quickly. One customer wondered what happens in a case where you've got larger number of devices. They've been talking about maybe 50 or 100 devices.
Well, I'd like to see the network design. If they were all concentrated on a single subnet for some reason, we would have to look at what an appropriate architecture would be. Because we're handling live traffic, there is eventually a sort of upper performance limit on a single SCADA fuse appliance, but that's very much volume based. So I would wager that you'd probably need multiple SCADA fuses in that scenario, but we'd want to get into the details and look at exactly what your use case was.
Yeah, another question is there a list of all the comprehensive protocols, known protocols that you support? And I'm assuming there's something on your website or the flyers that you've got.
There is, yeah. The data sheets that the AutomaTech team can provide have the current protocol list. And if anybody has any trouble digging those up, please let us know and we'll make sure to get them to you.
There was an additional question about importing network architectures, and I'm assuming that at this point we don't necessarily import architectures, we just observe traffic and report on it.
That's correct. Yeah, we are sort of asset centric rather than network topology centric. So we do deal with the assets we see, which is a combination of the IP addresses and the MAC addresses, and the SCADA fuse operates locally just on that scope.
Another question about notifications. What have you got in the way of built-in notifications? I understand that you can use the Modbus and be a device and be pulled by the PLC or the SCADA, and then obviously use things like Win911. But are there any built-in notifications?
Yeah, the built-in notification methods are typically syslog and email. Those are the simplest ones. We don't presume to have internet access for a SCADA fuse, so we don't use things like SMS gateway services on this particular product because we don't expect that we'd be able to connect to them. But certainly you can pump live verbose logs from syslog into any other analytics tool you have, and you can configure email so that it can generate email notifications whenever there's an event.
All right, I know we've got a few other questions here, but I think if you have a question and we haven't gotten to it, please get hold of us and we'll be glad to try to follow up with you and get them directly to Toby, but I don't want to cut our tempered friends off too much here. So Toby, thank you very much. Good job. And with that, we're going to bring in Brian Skoglund from Tempered Networks or Tempered IO.
Tom, hold on for just one quick second there. I just wanted to kind of introduce Kevin Davis from MCUA here. He wanted to just make a quick comment about Bayshore and SCADA. Kevin, can you hear us on the line here?
Yeah, I just unmuted myself. Hey everyone, how you doing?
Hey.
Hi, Kevin.
So actually, it was my question regarding the more devices. So we've used SCADA. We like it very well. So we've used the original one. But my question is, we have a lot of subnets, and so you have your iFix computer polling 50 devices, and the thought was, if your iFix computer gets compromised, could you put a device on the other side to say, hey, protect my 50 PLCs assets? And you do have a SCADA fuse, iFix SCADA fuse, I don't know the exact term. Would that sit on that side of the iFix computer, or would it sit more on the SCADA side where you would have historians and other devices polling the actual iFix?
Yeah, it'd be that latter one. The iFix variant will sit close to the SCADA servers for iFix itself. So it'll be on that local subnet where it reaches out to all the downstream PLCs. And you would typically, what we're looking for there is really protection from things like rogue, thin and thick clients, rogue nodes, view nodes, stuff like that, where they may have a copy of your license, but they're not meant to interact with your assets. Right, okay. So they're using legitimate instructions, but they're trying to do things that you don't want. So that's typically how the placement on the iFix version works, and we see it as working in concert with the endpoint version to provide full coverage on both ends of the connection.
Okay, thank you.
Sure, and thank you for your business, Kevin. We appreciate it.
Thanks for being willing to be put on the spot too. Thanks, Kevin. All right, Tom, back to you. Your show. Can't hear you.
Thank you. I need to just try to run through a couple of these last questions. If it's not a perimeter device, would you classify it as inline? I think the answer is yes. Can the SCADA fuse be deployed on the IT side of the HMIs? The answer would be yes. And what it can do to protect it would depend on placement.
Yep.
SCADA fuse notifications we've got. And can the SCADA fuse be set up to use MAC addresses only?
Indirectly. So we do have a feature for spoofing protection where we map MAC addresses and track the ARP table for the MAC to IP assignments. So we do always record an IP address. I think your question could be interpreted a couple different ways, and we can certainly chat about exactly what you're looking for, but I suspect we can probably accommodate it in one way or another.
And the last one is 61850. Is that on the roadmap?
It is on the roadmap, yeah. So Bayshore supports the IEC protocol family for some of its old traditional products. It's not in SCADA fuse right now because we chose to focus on water and some of the other verticals rather than bulk power. But yeah, we recognize that power and that whole infrastructure is going to be one of the markets for us.
Thank you, Toby. And we caught up with the questions.
Okay, great. Well, thank you all. I appreciate you giving us the opportunity.